All right, so when my directions say simplify, what's the first thing you need to do? Factor. You have to have factors to simplify, and then today we're going to multiply and divide, which is the same exact idea. You have to have factors. You can only cancel factors. You cannot cancel terms. So how do I factor x squared minus 4? Or what are my factors for x squared minus 4? X plus 2, x minus 2. What's that type of factoring called? Perfect squares. Difference of two perfect squares. That's x plus 2, x minus 2. And how about x squared plus 3x minus 10? What are my factors? X minus 2, x plus 5. Using my shortcut on that. And for all these problems that have simple factoring like that, difference of two perfect squares, the shortcut available for the AC method, I'm no longer going to write out all of the work for them. Because the factoring part of it's unit 1, what we're doing now is we're applying it. Now certainly, if it's something that you couldn't do in your head, like full AC method, something like that, I will still write out all the steps. But you're going to learn that you're going to have to become efficient factorers now in unit 2 because they're a small part of these problems. So are there any questions on where those factors came from? So once I have my factors, now what can I do? Cancel. Which factors cancel? X minus 2. As long as it's in the numerator and denominator, I can cancel it. Now, if you remember, we got to think back now because this was a week ago. Sometimes they just canceled. Sometimes they left a negative 1. Do these just cancel, or do I have to put a negative 1 in there? They just cancel. These ones just cancel because they're the same. When they're the same, they just cancel. So my answer then is x plus 2 over x plus 5. So for simplifying, for multiplying, and for dividing, we're just going to factor and then cancel any common factors. Now if you go back to your notes, we have one more problem to finish up in 7.1. So we got down to all of them but one. So on that last page of 7.1, example L, 5 minus x over x squared minus 25. It's the last problem in 7.1. So when you want to simplify, your directions are simplify. You've got to factor, cancel. Simplify, factor, cancel. So numerator is a binomial. There's no GCF. Nothing to factor there. What I'm going to focus on in this problem is factoring the x squared minus 25. How can I factor x squared minus 25? It's the difference of two perfect squares again. So we're going to have x plus 5, x minus 5, because 25 comes from 5 times 5. And then my numerator, I'm going to put it in parentheses, just because with these binomials, if they're not factorable, you have to be able to cancel the whole thing. So to show that a little easier, we're going to put it in parentheses. You got to be able to cancel the whole thing. Now, is there anything in this problem now that's factored that I can cancel? Okay, and Adam, what happens when I cancel them? There's negative 1 on top. So this is the case of our opposites. So the 5 minus x and x minus 5 are opposites, so I can cancel them, but they leave a negative 1. Now, why were these opposites? So 5 minus x, x minus 5. What's the difference between those, which we left a negative 1, and these, which were still subtraction, but we just canceled them? So these are the same order. So when they're the same order, even if it's subtraction, you just cancel them. If it's subtraction and a different order, that's when you get the negative 1. So what we're going to do now is we're going to actually go back to all of our rules for these simplify, multiply, divide problems and summarize them. And then we'll go into the other problems, which multiply and divide are the exact same. You just factor cancel. So let's summarize. Here we go. Oops, I went way too far. It's a big blank page. Here we go. Summarize the rules for simplifying. So there's only two possibilities, well, I guess there's three possibilities in simplifying. You cancel them, you get +1. You have opposites, you get -1, or they can't be simplified. So let's see. If we had a plus b over a plus b. So options, +1, which means they just canceled, -1 for opposites, or they can't be simplified. So what do you get if you have the same factor over itself and its addition? +1. Those would just cancel. What if I had a minus b over a minus b? +1 means they just canceled. -1 means they were opposites, or it can't be simplified. +1. They're exactly the same factor. They will cancel. What if I have a plus b over b plus a? +1, they just cancel. -1, opposites, can't be simplified. And -1, +1, any other votes? Break the tie. Another -1. So if we, Devin. Yeah. Addition is commutative. It means the order doesn't matter. So 2 plus 3 is the same as 3 plus 2. Subtraction order absolutely matters, but addition order doesn't matter. So what if I had a minus b over b minus a? Now it's a -1. This is the only case where you get a -1. The only case you get a -1. They both have to be subtraction, and you have to have that reversed. If they're both subtraction and they're exactly the same, they still cancel. But if they're both subtraction and reversed, that's the one and only time you get a -1. The only time you get a -1. And our last case, I have a plus b over a minus b. +1, they cancel. -1, they're opposites. Can't be simplified. So can't be simplified. So the one and only time we get -1 is this case right here. Nothing else gives me -1. So this can't be simplified. So most of the time you're just going to cancel, which means they match. Addition, the order doesn't matter, so as long as you have the same terms, they match. One case is opposites, they're both subtraction, flipped around, you get a -1. If your signs don't match, you have absolutely no chance of simplifying them. Questions? So what we're going to do now is we're going to multiply and we're going to divide, and it all goes on our same principles of simplify. So in simplify, we said factor, cancel. When you multiply, you factor, 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 cancel. So it's just more factoring in each problem. So multiplying fractions, here are steps. Oops. All right, you want to start by factoring all of the numerators and denominators completely. If it doesn't have a fraction, you can always write it over 1. And then we're going to cancel out any common factors. And after that, it's just like the simplify. You still have your possibility for opposites. If you run out of numerator factors, you leave a 1 unless you cancel opposites, and then you can leave a -1. So this first problem here doesn't actually have a whole lot of factoring in it. Now you could put some factoring in it, but we're looking to multiply, and you really need to think back to multiplying in your basic math. When I multiply fractions, before I multiply straight across, what I'm always looking for are common factors to cancel from the numerator and denominator. It makes my life easier. So if I look at the numerators here and the denominators, any guesses? And you don't have to be right, we're just guessing. Things you can cancel. Rob. The x's. X's are actually one thing you can't cancel here. So it's a great guess, and it's what people want to do. But when you have a binomial and part of the fraction, and this is why I say, put it in parentheses. That is a package deal. If you're going to cancel from that denominator, since it can't be factored, you've got to take out the entire x minus 2. So there's got to be another x minus 2. You can't take out individual terms. But that is absolutely what people want to do. So anything else that I might be able to cancel? 5 and 40. So 5 and 40 have a common factor. This goes back to more of like an 081. What can I divide out of both 5 and 40? 5. So 5 into 5 once, 5 into 40 8 times. And the reason I can do that is because they're monomials. When they're monomials, you can use old rules. But if you have a polynomial, you need to be able to cancel the entire factor for it. So now, anything else? No. So nothing with the x. I don't have another x minus 2. So now we're going to multiply straight across. X times 8 is 8x. 1 times x minus 2, x minus 2. And now we're back to separate terms, 3 separate terms. So I can't cancel from there either. If I was going to cancel something here, I'd have to have a GCF to all 3 terms. We talked a little bit about those 3-term fractions. So we're looking for common factors. If they're monomials, feel free to just divide right from them. But if they're binomials or polynomials, you got to be able to cancel entire factors. All right, B. It looks a little more daunting. People actually have an easier time with this type of problem, I find. What we're going to need to do is factor, 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 factor. Go through and factor every part of this. So let's start by factoring x squared minus 9. Devin, what do you got? Sure, difference of 2 perfect squares. And you're going to find that you're going to be a lot more comfortable with factoring by the end of Unit 2. So you're going to be able to pick it out easier because we're just going to use it like up to 4 times per problem. So that's my perfect squares. 3 times 3 gives me the 9, 1 plus 1 minus. All right, how about x squared minus x minus 12? Gary, can you help me out? Or tell me what I'm looking for in that type of problem. AC method, sure. So what am I trying to multiply to? So watch your side. Negative 12. So I need to multiply to negative 12. What do I need to add to? Negative 1. All right. So let's see. Kevin, you got a pair that multiplies to negative 12, adds to negative 1? Perfect. So x plus 3, x minus 4. It's going to multiply to negative 12, add to negative 1. I can use that shortcut and go right to factors because a equals 1. Many of your problems in this unit will have a equal to 1. So I'm not trying to kill you with all the factoring. You will find AC method, but a lot of shortcut. Yeah. Sure. Yeah. We're moving there. So times x minus 4. Can I do anything to factor x minus 4? No. It's not x squared minus 4. It's just x minus 4. So it's a binomial, which means if I'm going to cancel it, I got to take the whole thing, so I'm going to put mine in parentheses. And then my denominator is x. I can't do anything to factor, just an x. So now what we're doing is we're looking to cancel. Your canceling just has to occur numerator to denominator. It doesn't have to be in the same fraction. It can be. So you can either go, you can go diagonally, you can go up and down, any numerator to any denominator. I can cancel a common factor. So what can I cancel out in this problem? Chris? X plus 3, sure. Cancel exactly or leave a negative 1. Exactly. There's only that one case of opposites, we get the negative 1. So we'll just cross those out. They're the same factor. What else can I cancel? Those x minus 4s, do they cancel exactly or leave a negative 1? Exactly. The only time you get the negative 1 is if they're subtraction and one of them's flipped around. So they're subtraction, but they're the same, so you just cancel them. So what's left in my numerator? It's the numerator of my answer. What's left in my denominator is the denominator of my answer. And I can't cancel those x's now because they're back to terms. The x in the numerator is part of x minus 3. Anna. No, because if you multiply it by 1, you get the same thing. So if it's a positive 1, unless everything cancels, we don't usually include it. So, I mean, if you want to, when you're canceling, put 1s in, but when you're multiplying by 1, it doesn't change it, yeah. Questions? All right, factoring on C is a little bit more difficult on some of them, a little easier on some of them. So let's just go piece by piece. When you're asked to multiply rational expressions, factor, 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 factor. So first, can I factor 2y? No. No, I'm just going to leave the first numerator as 2y. All right, next thing I'm factoring is 3y minus y squared. When you're asked to factor, what's the first thing you should always look for in a problem? GCF. What's my greatest common factor here? 1. So I'm just going to factor y from each of those, and that's going to leave me with 3 minus y. So first denominator is just the GCF. What factoring method am I going to need for that second numerator? AC. Can I shortcut the AC? No. So we have A times C is 18, and B is -9. So I'm looking for a pair of numbers that multiplies to 18 and adds to -9. Anna, what do you got? -3, -6. Shelby, what am I going to do with that pair of numbers? So can I use the shortcut here? When can we use the shortcut? When A is 1. So I don't have A as 1, so I can't jump quite to my factors. Do you remember the other step? There was something else we did with that pair of numbers if we didn't go right to our factors. What in our polynomial here is equal to -3 plus -6? Yeah, it's the -9 in the middle. So if you can't go right to your pairs, it's always splitting up that middle. So 2y squared minus 3y minus 6y plus 9. And then Sarah, once I have 4 terms, what's that type of factoring called? Yeah, grouping. I'm going to do I use this squiggly line. I'm going to break them in half. GCF for each group. So I'm going to factor y for my first group. And then I'm going to need a negative GCF for my second group to get my signs to match up. It's going to be a -3. And then I have my factors are 2y minus 3 and y minus 3. So my factors here are 2y minus 3, y minus 3. So you will still see the full AC method in there occasionally. That's not going away. We'll be factoring again in Unit 4 at least as well. But all of Unit 2 is built on factoring. And the last thing I need to factor is 8y minus 12. GCF, what's my greatest common factor here? 4. Factor of 4. So leave me with 2y minus 3. So factor of 4. So when you're asked to multiply, it's the same as simplify, but there's just more things you've got to work with. Factor, 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 factor. Now we're down to the easier part in general, which is the cancel part. So, Mackenzie, can you give me one thing I can cancel here? Sure, 2y minus 3. It occurs in both the numerator and the denominator. Perfect cancel, or do I get a -1? Perfect cancel. They're exactly the same. They just go away. Anything else I could simplify? Chris, what do you think? Okay. Perfect cancel or -1? -1. That's your case of opposites. And that's how they kind of pop up in these problems. Anything else you think I could cancel? A lot of heads shaking no. So let's bring that over to the side. So I have 2y times -1, which is -2y over y times 4, which is 4y. Does it look like there's anything left that I can cancel? These are monomials. Yes. There are things I can cancel. What can I cancel? -2 and 4 will reduce to -1/2. And again, we could do this now because they're monomials. Monomials, we simplify like any other fraction. What about y over y? What happens when we have y over y? Those cancel. And we can do that because they're monomials. So that whole mess is -1/2. All simplifies down to a -1/2. And sometimes, now you could certainly simplify the 2 and the 4 back in this problem, the y's back in this problem, but I find it's usually easier for students if you, at that point, bring them over and give it one last check. Can I simplify? Chris?
If we wanted to simplify -2y, 4y will be evolved points to 1. If we just left it like that, would we evolve?
Yes, because it's got to be simplified completely. So that 2 over 4 needs to go down to 1/2. But at the end of a problem like this, it's probably like a point. Any other questions? All right, let's do some dividing. Now, there's one different rule when you divide fractions. Who remembers how you divide fractions? Flip the second fraction. You multiply by the reciprocal of the second fraction. Now, you only do this if it says divide. If it says multiply, you just start factoring and canceling. If it says divide, in your directions, your problem is division, you've got to make sure at some point in the problem you use the reciprocal. You flip over that second fraction, and the multiplication turns into, the division turns into multiplication. So this problem is x squared over 8 times 4 over 3x. Now again, the monomials can be a little bit trickier to simplify. I just find, for whatever reason, the monomials are harder. So you certainly can start canceling here. Does anyone have anything numerator to denominator that I could cancel here? Do I have the pulling? 4 and 8. So 4 and a 4 once, 4 and 8 twice. Anything else I could simplify? One x where? 1x in the numerator. So the x's, they're monomials. And when we divide, what do we do with the exponents? Subtract them. So even though they're not in the same fraction, I'm still dividing them because one's in the numerator, one's in the denominator. So I could subtract the exponents, and that's going to leave x to the first in the numerator. And then I have 1 times x is x over 2 times 3, which is 6. But again, I find sometimes that, especially with the monomial variables, can be harder to see. So your other option would be to start your problem by just multiplying straight across. And I'd only recommend this for monomials. So you'd start with 4x squared over 24x. And then you could simplify. Don't just multiply, make sure you multiply and then simplify. But it's now, when I simplify 4 over 24, what's my common factor for 4 and 24? 4. So 4 and a 4 once, 4 and a 24 6 times. And now it might be a little bit easier to see x squared over x. We did that all the time in factoring. I can simplify x squared divided by x to be just x. So I still get my x over 6 out of that. So if you have a hard time with the monomials, I recommend after you've got your setup, multiply, then simplify. Instead of trying to simplify, multiply, maybe missing something, simplify again. I find this tends to work a little bit better for people with the monomials. Now, our larger problems, like B, work just like the multiplication problems, except when you see divide. And only when you see divide, we're going to change it to multiplication and use the reciprocal of the second fraction. Flip it around. Now, you do not necessarily need to rewrite the whole problem. I'm just going to rewrite this flipped around so that when we get our factors, we make sure that we put them in the right place for a division problem. So this is what our second fraction should look like. We're going to use the reciprocal, and the division is going to become multiplication. And now we're back to factor, 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 cancel. So I need factors. Problem is now multiplication since we flipped around that second fraction. So I'm going to need to factor, 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 factor. So for number 1, x squared minus 5x minus 36. I'm looking for a pair that multiplies to negative 36, adds to negative 5. I can use the shortcut because a equals 1. So raise your hand if you got a pair. Multiplies to negative 36, adds to negative 5. Adam. Okay. X minus 9, x plus 4. Good. First denominator, x plus 5. Any factoring to do there? No, it's a binomial, so I recommend you copy it down in parentheses so when you cancel, you make sure you take all or nothing. All right, next we have x squared plus 4x minus 5. Sing. You got a pair? I'm trying to multiply to negative 5, add to positive 4. X plus 5, x minus 1. Yeah, you get your pair, 5 and negative 1. So multiplies to negative 5, adds to positive 4. And then last, I'm trying to multiply to negative 9 and add to negative 8. Brittany, got a pair for me? Negative 9 and positive 1. So x minus 9, x plus 1. All right, Shakira, you got a pair I can cancel? X plus 5, sure. Numerator, denominator, gone. Sheena, something else?
X plus 9, x minus 9. Wait, no, x minus 9,
X minus 9, x minus 9. So cancel those. Anything else? So the x's and the 1's. Now if we go back, and those do get canceled a lot, if they don't have the same sign, even though they look similar, and they'll be in there in those problems to see if you remember this, can't be simplified. So we got to make sure both addition, both subtraction if I'm going to cancel them off. So it's tempting. So they both have x, they both have 1, but this pair, unfortunately, we can't cross out. So we're left with 3 factors this time, which is okay. X plus 4, x minus 1 in the numerator, and you do not need to multiply those out. You do not need to waste your test time, your drill time, whatever, foiling those out. You're welcome to leave just the factors. So you do not need to foil those out. Just make sure it's in parentheses and you can leave your factors. Questions? Chris? You can. You don't, when there's only one, you don't necessarily need the parentheses, and since we know we're done canceling, but yes, absolutely. If you put that, I mean, there's no foul in putting that in parentheses. But since we're done, we know we're done with it, and it's only one, we don't necessarily need them here. Any other questions? All right, for C, dividing again. So when you don't have a denominator, you can always make that look like a fraction by putting it over 1. And because the problem is division, directions are divide, division symbol, we know we're going to need to change division to multiplication and use the reciprocal of the second fraction. So I'm going to have something over 1 times, where I get my factors here. So factor, I don't really have to factor 1, factor. So x squared plus 4x minus 5. Maybe I actually had that in the previous problem. Need to pair that multiplies to negative 5, adds to positive 4. Tiffany, what do you got? X plus 5, x minus 1. Multiply to positive 5, sorry, negative 5, add to positive 4. I'm not going to factor 1. So next, x minus 1, can I factor it? No, but it is a binomial, so when we get to the factoring stage, it's all or nothing. So the canceling stage. So I'm putting in parentheses. And then how about x squared minus 25? X plus 5, x minus 5. Difference of two perfect squares. And now what can I cancel? X plus 5's gone. What else can I cancel? No. It has to be numerator to denominator. That's why there's examples in here. So you got the same factor, but they're in the same part of the fraction, which means they've got to stay. They both have to stay. You only can cancel numerator to denominator. So my numerator is left with x minus 1, x minus 1. My denominator is left with x minus 5. To save yourself some writing, the way I think you see it in the back of your book is x minus 1 squared over x minus 5. But either of those is acceptable. But when you have the same factor twice, normally you'll see the final answer written as your factor squared. Questions? With this one down here? No, because 1 times x minus 5, still x minus 5. So if you have positive ones floating around and you have other things, we usually leave them off because when you multiply them together, they don't change what you have. If it was a negative 1, we'd have to bring it. But positive ones, you could. That's really probably not considered simplified because you could multiply 1 times that and not bother with the 1. I usually don't take off for extra ones. Yeah. Any other questions? All right, so we're actually in really good shape for today. So we have 15 minutes left. I have 3 problems.